Welcome to the Modeling Quadratics and Vertex form lesson. So today will be one of the first lessons where you're building a quadratic equation from some clues or a graph that you can see and so forth. You will also study some other forms called like the standard form of a quadratic and the factored form of a quadratic. So for today, we're just looking at the vertex form. It's something you've actually already seen already and have graphed it. So we're just going to do a little bit of a review and then we'll move on to the new stuff. So if you don't need the review, as usual, just kind of skip ahead to when we get to this second page here, okay? All right, so for now, so we've been slowly studying the quadratics, like what we start with y equals x squared, and then if we, add a k value, what happened to it? What if we put x in a bracket with an h value? What would happen? And then what would happen if I put an a in front and I made it negative? What would happen? And then if I made it a number between 0 and 1 and a number greater than 1. Okay, so we've studied all of those and we looked at how the graph shifts and moves and transforms. So we're kind of going to work backwards now. Because before I'll give you the equation, then you go graph it. So today what we're going to do is I'm going to give you the clues about the graph and so forth, and then you have to build this equation using the clues. Okay, all right, so let's just do a review doing it the way we've starting with the equation and just doing that review, and then we'll get to the new stuff. So the first type of transformation that you studied was the vertical shift or the vertical translation. So that's moving it up and down. So if you had a positive k, like a +5 or +3, you knew that it moved up 5 or 3. If it was subtract k, you knew that it would go down by, so if it was -3, it would be down by 3. So -4, down by 4. All right, and then here in the brackets, we were looking at, think of it as what you see there is the opposite, it moves the opposite way. Okay, so if you saw an x plus h in here, a plus h, it would actually go left, okay? And if you saw just x minus a value, so x minus 5, it would actually go right 5, okay? And then the a value here, remember if it was negative, it would reflect in the x-axis. So for the a value, if you have a value between 0 and 1, it's a vertical compression by factor of, and this should say 1 over a. Oops. 1 over a, like that, okay? So remember, take the fraction for a and flip it, okay, if you have a fraction there. And the vertical stretch is, if it's greater than 1, so 2, 3, 10, you say vertical stretch by factor of a. So that's what we've covered so far. So we're just going to do a quick review. Given the equation, we've concentrated a lot on just graphing stuff, but today we're going to just do a review where we're just grabbing the values of a, h, and k and then describing it, okay? All right, so looking at the first one here, y equals 3 times bracket x minus 2 squared plus 1. I want you to go through and analyze the general equation. So this is called the vertex form. Okay, so get comfortable with using that terminology because you will start to analyze in this cycle a few other forms as well. Okay, so this is the vertex form. Again, we kind of looked at it. It's because you can find the vertex. It's the h and k here in the equation here. Okay, all right, so for now, let's just kind of get to that review here. So we're looking at the first one here. What is the value of a? Okay, so that's the value that would be in front of the bracket or the x squared here. So there's our a right there. It's 3. So we're just going to put in 3. Okay. All right. So what is the value of h? Okay. So remember the general form is x subtract h. So it's the opposite. H is the opposite of what you see here. Okay. So if it says subtract h, you have actually a positive h value. Okay. And if it's add h, then you actually have a negative value in there. So let's just practice here. So we have here, this is our h right there. So our general form is always x minus h. So since we have a minus 2 here, the h is the opposite, okay? So it's positive 2. So just think it moves right 2. So the h is a positive 2. All right, the k is a positive 1. That's what you see, okay? And so then from there, I want you to tell me the vertex. So the vertex is hk, 2, comma, 1, okay? So we practiced that last time where we looked here, we could see that the vertex was, okay, the number, whatever number was here was the opposite, and then the k value is what you saw. So if you see a minus 2, you actually write positive 2 and then positive 1. All right, and if you're describing the transformation here, so compared to the original y equals x squared graph, what happened here was, well, the 3, the a equals 3 value is a vertical stretch by a factor of 3. And then you went right 2 and you went up 1, okay? So, and then there's your vertex. So again, we are just doing a review here, just kind of jotting down kind of the values that make up the equation here, okay? That kind of helps us lead into the new stuff. So, yep, just keep going through here and filling out the different parts here. All right, so I'm looking at the next one here. What's the a value? So in this case here, I'm noticing that we do have a negative 1/2. Okay, all right, so make sure you write that. And then the next one here, the h value, so h is in here in the brackets, right? So it's always the opposite of what you think, so C there, so it's, yeah, it's +1, so you would write -1 for h. Okay, the k value is just the +5, positive 5, so therefore the vertex is -1, 5, like that. Okay, all right, and then go through and describe the transformations. Okay, so since a had a negative, that means that there's been a reflection in the x-axis. Okay, so that's just the negative part that we looked at. Okay, then we're looking at the actual value here, the 1/2. So it's a fraction, it's between 0 and 1, so we have a vertical compression. Okay, and then we flip the fraction by a factor of 2. Okay, we know that it was +1 here, so that means it moved left 1, so, and then it went up 5. Okay, so the vertex is left 1 and up 5, and that's where the new vertex is. All right, so on to the next one. So in this case here, what is the a value? Well, the a value is sitting right in front of that bracket, and if you look right here, there's nothing there, so an actual value of 1 is actually there. Okay, so just keep that in mind. Okay, so when it's 1, all right, there's no, vertical stretch. Okay, it's a positive, right? So there's no reflection. All right, so let's just look at the h and k now. So h, again, is the value that is in the brackets here with the x. Okay, so it's +2, so we think the opposite, subtract 2. Okay, and then the k value is +15, and therefore the hk, that's your vertex. So that's how you find your vertex quick. Okay, so again, you'll look in here, the opposite sign for the x value of the vertex, think of it that way, or the h value, and the k value, which is like the y value of the vertex, is just what you see, +15, +15. All right, and go through and add the transformation description. Okay, and so again, there was no vertical stretch or compression or reflection here because a is equal to 1. So the only things that happened here are that it's that move left or right, up and down. So left 2, up 15. Okay, so start analyzing the next one. Okay, so now we're not seeing those brackets that we normally would see. So like when you look at this one here, so x is in a bracket with some value, so that would mean it was a left and right movement. So right now we don't see that here. So if you see x and it just says x squared, I know that that means that you are not moving left or right, okay? But there is an a value, so there's a number sitting in front of the x squared, right? It's in front of this area here, so that's the a value, so that's what we're going to write in. So that's 2, and it's +2. All right, and so again, there was no left or right. There's no h value. So if there is no h value, that means that it was a movement. There was no movement, okay? So it's just you write in 0. But then we do have a k value, 9. So it went up 9. All right, so what is your vertex? If you know it didn't go left, because remember you start at 0, 0. If it didn't go left or right, you're still at 0, but then you went up 9. So your new vertex would be here. Okay, so again, reminder, it's H and K. Think of vertex as being H and K. All right, and I'm going to quickly just do the last one here, and then we'll write in the descriptions here. All right, so here we have a -3. Okay, so for the A value, here's where the H will be found inside the brackets. So it's +5, so think the opposite, -5. And then now the K, which is always out here, past the exponent, I guess, and there's nothing there, okay? So that just means that it, because remember the K value determines if you move up or down. So if there's nothing there, it didn't move up or down. So it just, the K is 0, okay? So when you write in your vertex, it's -5, 0. So think of it like you had a quadratic equation. It started at 0, 0. When you had the +5, it made it move left 5. Okay, and then you put a dot there. But it didn't move up or down, so that's why it goes -5, 0. All right, but there is a vertical stretch by a factor of 3 and a reflection in the x-axis here. So let's write the descriptions up now. So I went ahead and wrote in the transformation descriptions now. So again, compared to the original parent, y equals x squared, how did this change? Well, when we multiplied the 2 on here, +2, so there's no reflection, but there is a vertical stretch by a factor of 2. And the x value here isn't in a bracket with a value, so there's no left or right movement. Okay, so I'm not going to state that, but this 9 says up by 9. Okay, so there's 2 transformations here. All right, the next one here, we had a negative, so there was a reflection in the x-axis. 3 means that there's a vertical stretch by a factor of 3. Okay, I've been worried a bit little because some of you have seen the negative and assume right away it's like compressing, so you keep writing compression. Okay, so just think the negative is just the reflection. Think of the negative as the reflection, and then just the 3 alone, we're looking at, is it a fraction or is it a whole number, right? So if it's like 0.5, 1/4, 3/4, so it's between 0 and 1, then it's a compression. But otherwise, if it's bigger than 1, you have a stretch, okay? So just kind of sort that out. And here we have it in brackets, so that means left or right. So we went left 5, the opposite of what you see, left. So it's +5, we actually go left. And there's nothing out here, so we don't say up or down. Okay, so just 3 transformations here. So make sure that you're confident with those. That's just kind of a review from the last cycle. All right, so now if with that confidence, we're going to move on into the new stuff. We're going to actually, if I give you like maybe these clues here, like, oh, there was a vertical stretch or the vertex was here, can you actually go backwards and build the equation? Okay, because you've always had the equation and you graphed it. You had the equation and then you found things like vertex or described it. But now we're going backwards to here. Okay, so please, yeah, just kind of review this. Make sure you're good at it before you start the new stuff. Okay, so now that we've reviewed all the things that you've covered in the last few cycles, hopefully you can build this vertex form equation today. So here's the general form. So your goal today is to find 3 things. You need to find the A, the H, and the K. Okay, it's kind of like before, and I don't know, like the first cycle when I said go and build the equation of a line. So you guys had to build this equation, y equals mx plus b. So what were the 2 things that you always had to find? If you can find m and you can find b, you can build your equation. All right, so same idea here. You're just using a different relation now. You're using a quadratic relation instead of a linear relation, and you are building this general form now. So the 3 things that there's 3 things that you have to find. You still have your x and y in your equation, but you need to find your a value, your h value, and your k value in order to build your vertex form of a quadratic. Okay, so that's all you're doing today. It's kind of the same idea. You're taking clues that you see. Sometimes if you have a point, remember whenever we had a point with these ones here, you knew, oh, I can plug it into x and y to help me find one of the letters and so forth, okay? So the same idea here. If you have an x and y, and then you have some other clues, you can fill some stuff in, and then one of the letters will be left that you have to solve. So let's start with the first one. Okay, so here I'm just already giving you tips here. The vertex, if you ever see that, you know you can fill that in, okay, because that's what H and K are. and you have another point, right? You plug in the x and y, and then you can solve for a. All the questions aren't going to always be like that, but just that's like maybe the tougher ones will be like that. So just keep that in mind, okay? So same idea with what you did here. You guys practiced a lot of these and you got good at them. So, all right, example one. So we have the following transformations were applied to the parent y equals x squared, okay? I want you to determine the vertex form equation. So now get used to that terminology, vertex form, okay? If I say vertex form, you should know right away I'm talking about that equation above there, okay? So what I'll do on assessments is I'll give you that, okay? And then so you know, but I won't like actually write vertex form by it. I'll just give you this equation. You need to be able to identify that's the vertex form, okay? All right, so I want you to build this equation here. Here are the clues. There has been a reflection in the x-axis, a vertical stretch by a factor of 2, followed by a translation 3 units to the left and 1 unit up. Okay, so it's telling you what happened to the graph. So it's like me telling you like this section here. I'm giving you that description. Can you go backwards and build the equation? All right. So again, you learned that reflection. Where is the reflection always found? Right where the a value is. Okay, so you know. Okay, well then the a value we know is negative. Okay, that's what that piece is there. The reflection in the x. All right, it also has a vertical stretch by a factor of 2. So where's the vertical stretch and compression? Same thing, right where the a value is. So we know it's a factor of 2. So we can say the a is negative 2, okay, because we know reflection and vertical stretch. Okay, so maybe I had it at the top, but maybe I'll just kind of write these notes in here as well, just so you can use it as a reference. So that's the reflection. This is the vertical stretch or the vertical compression. This is, remember, the left and right movement, and this is the up and down movement, okay? All right, so, okay, reflection in the x, vertical stretch by a factor of 2. Okay, we got our a. I'm telling you that there's been a translation left, okay? So this one here, what letter is that? Okay, because here, these two here, these were the letter A, but what letter is it when it goes left and right? Oh, right, it's the H, okay? So on top of it, I told you that it went left by 3. So for now, if it went left, you're going to write down -3 to show that it went left. But then when you plug it in, you're going to have the opposite in there, plus H. So we'll see that in a sec. 1 unit up. So again, this is the K value, and it went up by 1. So we're just going to write 1. So let's build our equation. So we're going to write our general form here. Okay, so the a value is -2, so let's fill that in. Okay, now the h, see how it's -3? So I'm going to plug it right in where the h is. Okay, so I'm just going to plug it in. So whenever we sub something in, we put it in brackets. All right, now I'm going to put this bracket squared plus k, which is 1. So we never leave our equations like this. If we can clean them up, we should do that. So see how like a negative here becomes a positive. So this final equation should look like that. Okay, so do we have a reflection in the x-axis? Yes. A vertical stretch by a factor of 2? Yes. We moved left by 3. Yes, that's right, right? Because if it's +3, we actually go left. And we went up by 1. All right, so that's what you need to do here in order to build your equation. You need to find the 3 letters in the clue it was given. All the things were given. Then you just had to write your equation out and then write and clean up any like signs that are like that. So again, if you want to know how I would mark this, I'd give you a mark for the K, for the H, for the A, and then an overall mark for like having Y equals, and then, you know, remembering the square here, remembering brackets and so forth, okay? So 4 marks for that. So make sure everything's there, everything's cleaned up, and everything's in the right place, okay? So make sure, like even if you wanted to, like once you build your equation, go backwards and go, if I were to describe this, would I get these descriptions? So negative reflection in the x, yes. Vertical stretch by a factor of 2, yep. Okay, left by 3, yes. And up by 1, yes. Okay, so that's how you go kind of back and forth, okay? So you know you're doing it correctly. All right, let's move on to B. All right, so we have a vertical compression by a factor of 3. So vertical compression. So again, where is the stretch and compressions? Well, it's the A value. So we know we're talking about the A value here. And from there, we know it's a factor of 3, okay? So remember when it's compression, remember how you always flip the fraction and write 3? So if it was a compression, if it was A was 1/2, you would write vertical compression by 2. So here, it says a factor of 3, but remember you flip it. So it's like you have 3/1. Now flip it to go back to the A value, okay? Because compression should always be a fraction. So vertical compression by a factor of 3 means 1/3, okay? And then we have a vertical translation up by 4. It says nothing else though, okay? So up by 4, up and down, oh, that's the K value, okay? So that one's up by 4. All right, and then see how it doesn't tell you left or right? There's nothing about left and right, so that means H is 0. So now go build your equation. So I always write the general form out. Okay, and then if you guys keep doing that as well, you get it memorized, you get comfortable with it, you'll be able to identify it quick. And then just keep saying in your head vertex form, okay? All right, so A here is 1/3. That matches my vertical compression by a factor of 3. And my x value here, so H is 0, right? It didn't say anything about the left and right, so you assume 0, and then K went up by 4. There it is. Okay, and then you always want to clean this up. So x minus 0 just becomes x, and then since it's not with anything, you don't need the brackets either, so you just write x squared. So it'll be 1/3 x squared plus 4. That's your final equation. Okay, so again, I would give it 4 marks. I would give you a mark for the K, the mark for knowing that H was 0, a mark for the A value, and then seeing the Y equals X in there with the squared. That's your 4th mark, okay? All right, so hopefully it's going okay. You just, again, if you're not sure if you did it right, go backwards now. Go, oh, okay, if I have this 1/3 there, how would I describe it? Oh, I would say vertical compression by a factor of 3. That's correct. And I would say up by 4. Yep, that's correct. Okay, so on to the next one. So again, even if it helps you, you can say reflection. Okay, I know that's the A value. Vertical stretch. Oh yeah, that's the A value too. The new graph has zeros. Okay, and a point. Okay, so there's some new terminology here we'll go over. So for now, we know there's been a reflection. So that means it has to be negative. And a vertical stretch by a factor of 2. So stretch. So we know it's just use whatever number you see there too. Okay, you're not going to flip it. So we know that there's a point, x and y, so we're going to call this one x and y. And then the new graph has zeros at 3 and 13. So I want you to get comfortable with the word 0. 0 just means it's like, so if we see here, 3, doing a rough sketch here. So we know that, okay, we know that this graph opens down too, right? It flips down. So let's just do a rough sketch. We don't know exactly how big this graph is, but we know it has the zeros here and here. So what that means is it's another name for the x-intercept. Okay, so we have zeros. Okay. Okay, so we know that the graph looks similar to what we have here. We know that it has to hit at 3 and 13 on the x-axis, okay? So that's why they call it zeros. So whenever the y is 0, okay, we have some x values of 3 and 13. So we know this. So how do we go about building and finding information to build this equation here? Oops. Minus plus k. All right. So your goal is to find a, h, and k. All right. So right now, the only thing that you have is a for sure. We don't know. There's no clue about if it moves left or right or up and down. We do have this one clue here where it's telling you, well, there's a point somewhere on the graph 418. So like maybe about there is 418. Okay, not to scale. So, but that doesn't help us. Like we don't know if it's left or right, up or down exactly. So we're just going to go back to something we did a few cycles ago where if you have a couple of points and they're straight across from each other, so if it says they're zeros, they're straight across from each other in the quadratic. So in that case there, we know that the vertex is here. Okay, that's where the vertex would be. And we know that the axis of symmetry goes through the vertex, right? So we know we could figure out, because like the vertex we know is always like y and x and y or h and k now, right? Those are the letters that we've been using more specifically for vertex. We know that we can find the first value of the vertex by finding halfway between these 2 points. Okay, so that's what we'll do first. So we'll find we'll call it the h value of the vertex. Okay, so it is like the x value, but we're gonna try to differentiate it from this point that we already have. So the h value of the vertex, we're gonna find it by taking these two numbers of the zeros, 3 and 13, and we're gonna find halfway. So we're gonna take them and add them and divide by 2. Okay, so it's like finding the average. Okay, but I think a lot of you were able to guess, oh yeah, that's 8, that's 8. Okay, so we know that right here is 8, okay? So we know the vertex, the first value is 8 something, but we don't know how high it went, okay? So for now, though, we have the h, so we could find the h value, how high it went, if we had an equation, but we don't have that either, okay? That's something we did in the past where we had the equation. If we had the x value, we plug it in, and then we could find the y value for the vertex. So we're going to just try a different strategy here. So for now, we know a, we know h now. So let's just plug in what we have. So I have, so I can plug in a first, negative 2x minus 8 squared plus k. All right. So I know my h, I know my a. We don't know k, and then we have x and y not filled in here, but we actually know x and y. So let's plug those in as well. So whenever you have a point, always plug it in, okay? That'll help you solve for the letter that's missing. So if I put y in there, x is 4, and then that leaves k, and that's what our goal is. Sometimes we just got to plug some stuff in order to solve for the one last letter that we need, okay? All right, so go through, clean it up. So I'm going to take care of the stuff inside the brackets here first. Okay, so it's almost like you kind of calculate out and then you start solving. So BEDMAS will say, okay, take the brackets first, now do the exponent. Okay, so you're going to square them, it gets to positive 16. 16 times negative 2 will become negative 32. Okay, we're almost to k. All right, now just boot that over. Becomes a plus 32 on that side. And then your k value will be 50. Okay, all right, so a lot of information here that we had to kind of decipher and then get to little pieces of the equation and then get to the last piece of the equation. So now we have k, okay? We have k, we have a, we have h, okay? So now we're going to build our equation. We have all the letters that we need, a, h, and k. I'm just going to write the general one again. Okay, and now we're never going to, when we're writing our final equation, remember, don't fill in the x and y, just, we had to do it in order to find some missing letters, but now when we write our final equation, we leave them as x and y and fill in everything else that we know. Okay, all right, so from there, you can see that this graph, this rough sketch that we made, oh yeah, the graph moved over 8 and then up 50 for the vertex, and then looks, can't really tell by our sketch, but it's supposed to be a vertical stretch by a factor of 2, and then it did reflect. So there's your equation, and I know that was a lot of work, but same thing, there's 4 marks. I want to see that you found the A value, you found the H value, you found the K value, and then your general, everything else, y equals, brackets, the form, okay? That's what I'm looking for. All right, so again, if you want, start a new sheet, try to practice that one again. Go through the steps of, well, okay, it told you A right away. Whenever it tells you about zeros, know that, oh, okay, that means I can find the x value, so the h value. You can find the h value right away when you know 2 zeros like that, because that's just halfway. So once you have those, you can plug them all in, plug the point in that you know, find k, and then solve it. All right, so let's move on to another one. All right, so given the vertex and a point, find the equation. So some new, different information, okay? Hopefully you realize that your final goal is to build this equation, okay? So you know you're finished once you find these 3 letters. Okay, so let's look at the information that's given to us. Determine the equation in vertex form. Okay, so that's vertex form there. And the vertex is at, these values here. So remember, vertex is a point, but it's a special point, and we're going to use the letters H and K to describe them. Okay, and then it passes through a point. So some other point that's on the parabola that's not the vertex, we always just use X and Y as those values here. Okay, so now you're going to go through and fill in everything that you have. So we know y is 4. We don't know a. We do have x. Subtract, h is -3, so write -3. Okay, be careful with those signs. And plus k is +2. Okay, so I filled all the letters in except A, and that's okay because that's the one letter we don't know how to find. So if we know everything else, we can solve for A. So for now, let's start by cleaning up this equation here. So that becomes +3. Okay, so -1 comes in, battles 3. Positives will win by 2. Okay, and see how I keep writing everything exactly the way, like I'm just going through them, cleaning up the brackets. Okay, I did the exponent now. But see how A has always been right beside here? So keep in mind, this means multiply. Okay, so for the next line here, you can write it like this. It's still the same. 4 times A is the same as 4 times A this way. So A times 4, 4 times A. Because I know you're used to seeing the number on this side. All right, so from there, solve it. Okay, so we have 4 and 2 on there. We're going to move this one first because we're using SAMDEP. Okay, so it's +2, it becomes subtract 2. All right, so now we'll check the 4. See, it's multiplied now, so it divides away. And we're out of space here, but A becomes reduced 1/2. Okay, and keep it as a fraction. Right? So then you're like, oh, I'm done. I did a bunch of work. Nope. What was your goal here? You had to determine the equation for the quadratic. Okay, so now that you found all the letters that you need to write your final. So therefore, this is your final equation here. So here, I'm just going to write in the general equation again, just so I know I'm filling in everything correctly. So remember, x and y, don't fill them in, but we know our a now. A is 1/2. X is x, we're not going to fill it in. H is, so see how it goes, negative, subtract, but then you put in a -3 into h, and then +2 for k, and then please clean it up. Don't leave the signs like that, okay? So if you can do that one step like this, that's good. And there we go. Okay, so that's your final equation that you need. Again, 4 marks there. So again, hopefully this is feeling a little familiar when we had to build the y equals mx plus b equations. Sometimes you would be given 2 points. You have to find the slope, then you find the y-intercept. Sometimes you're given the perpendicular slope, so then you had to kind of go through and take everything you had and use it in order to build your equation. So it's the same kind of idea, but now we're just working with parabolas, okay? All right, now we're moving on to the last questions here. So for the first 3 here, they were four. You were given descriptions, some clues, and you had to build your equation, okay? So now, the last type of question that I want you to get comfortable with is if I give you just a picture, okay, of a quadratic, can you build this equation, okay, the vertex form? So again, can you find the A? Can you find the H? Can you find the K? Can you kind of go backwards with everything that you've been doing and get back to this equation here? So we'll start off with the first one here, and we'll make it a little larger here so we can see better. Okay, so again, our goal is to find y, the vertex form. Okay, vertex form, vertex form, vertex form. Okay, so y equals A, x minus h, bracket squared, plus k. So again, remember that you have the parent. Remember it was always, right, the vertex was right there. So if it was y equals x squared, you know the vertex was at 0, 0. Okay, so where is this vertex now? You know, there it is. So let's look at, okay, so we'll write it here, I guess, vertex. So remember, it's your, so just let's write it down first. Okay, so right now the x value is 0. It didn't go left or right, but it did go down 1, 2, 3. Okay, down to -3. So again, there's your vertex. That is your h and k that you've already found. All right, so that leaves us A. A's left. So from there, there's lots of different ways you can approach this. So you know that you could find A if you found another nice point. Like here's a nice point here. So that's like 2, 5. So this is like a XY point. So you can plug it in and solve for A. I just zoomed in a bit more. Some of you might want to look at and see if you can see the step patterns. That's another way that you can go about doing this. But it has to be that, you know, you're actually seeing some good points here. If you're not seeing the good points, then you want to try to find a point that matches and then find it algebraically. So let's actually do it both ways right now. I'm going to start with just finding it algebraically. So we know there's a nice good point here, 2, 5. Okay, so we have a point. So we have a point 2, 5. Okay, so we have our vertex and we have our point. So we can build our equation algebraically here by plugging everything in that we know and finding the letter A that we don't know. Okay, so y is 5, A we don't know, x is 2, subtract h is 0, and k is subtract 3. All right, so go through and solve that. Okay, so again, I'm doing brackets first, then I'm doing the exponents next. Okay, and then I'm going to write this as 4a minus 3. And then let's boot the 3 across. Get to 8. Running out of space, we'll go underneath this homework part. So we're going to boot the 4 over now. So 8 divided by 4, because right now it's multiplied by 4. And a becomes 2. Okay, so there's a. So if we make our final equation here, Okay, so a is 2, x is, well, we don't fill it in, h is 0, and k is -3, so let's clean it up. Okay, so again, x minus 0 is x squared. We don't need the brackets, so just write 2x squared 3. And that is your final equation for this picture here. Okay, all right, so that's kind of, by plugging everything, like plugging a point, plugging the vertex in, that's that way of finding the equation. So let's try the other method as well. So I'll go in a different color here. Okay, so again, you would just start, so that was like method 1. Okay, this is method 2. Okay, so method 2 is going to work here because it looks like we do actually have some nice points here. So for now, we know this vertex here. Okay, so now what we're going to do is we're going to analyze the step pattern, okay, because we know our h and k. So we're going to try to find our a value by using the step pattern. Okay, so from the vertex here, we're going to go over 1 and up. How many do we go? So we go over 1, up. Oh, we went up 2. Okay, so then we go over 1 and then up to here. Okay, so that's 1 square, 2 squares, 3 squares, 4, 5, 6. Okay, over 1. We can't see the next one, but we can see that it's a 2, 6 pattern. Okay, so remember, we take our a and we multiply by 1, 3, 5, etc. Right? So if we got 2, 6, we don't know the next number, but we could probably guess it. What was a in order to make 1, 3, 5, 2, 6, etc.? Okay, so what would I have multiplied 1 by to get 2? What would I have multiplied 3 by to get 6? Oh, a would have had to have been 2. Okay, so if we have a really nice graph, this is maybe a quicker way of finding the equation as well. So you can use any of these tools, like you've learned how to use the step pattern tool, you've learned how to plug points in and so forth, so they both work. So it's the same as here. We found a was equal to 2, right? But we know a, h, and k already, so we're going to build our equation here. Okay, there we go, and then clean it up. You don't have to have any brackets or zeros in there. Get rid of them. Okay, and write your final equation. All right, so there's method 1, there's method 2. So method 1 is nice. It's algebraic. It's you're going through, you're calculating values out because you know certain points and so forth. So you're good. Method 2 works only if you have a nice graph. Okay, we could see that these points hit at really nice points. So if you're going over 1 and it only goes halfway up or a quarter of the way up, that's when it gets tricky. You shouldn't use this method because we don't know if it's exactly 1/2 or if it's a third, or so that's why using the algebraic method here where you plug things in is a lot better. Okay, all right, but still I want you to always see lots of different ways of doing things. So okay, so let's move on to B now. Okay, and this is our last one. So again, feel free to use whichever method, but so the main goal here is try to find as much exact information that you can from the graph. You shouldn't be estimating a point and so forth. It should be like going right through the crosshairs, so you know exactly what point it is and so forth. Okay. All right, so again, your goal is to find A, H, and K. So right away, we know the vertex. You can find that from a graph. Okay, so we're looking here. It's right here. So X, well, we're in -3 and it didn't go up or down. So we have -3, 0. Okay. So again, right away, when you find your vertex, you found the HK part of your equation. So now our goal is to go find A. So again, we can do what we did with method 1, go find a nice point, like here's a nice point here. Some of you might go, well, it looks like we have a nice step pattern here. Okay, so you can use a step pattern as well. So I'm going to help you find it both ways so that you can, so we'll call this method 1. Okay, so you can kind of do it both ways, and so you can double check. So method 1, we're just going to say take a nice point, another nice point here. Don't take the vertex again, but take another nice point. So this is going to be -5 and -4. Okay, so double check it, -5, -4, yeah. Okay, so we have our point. Okay, and again, these are both points, but this is a special point called the vertex, so we're going to use HK. This is just some other point, so we're going to call it XY and use our general equation here to find the last thing that's missing, which is A. Okay, so plug it in, -4, A we don't know, H is -5, H is -3, and K is 0. Okay, so I'm cleaning up in the brackets here, so -5 plus 3, and I'm not going to write that 0 anymore, -5 plus 3, because the negative makes positive. All right, so -5 comes in and battles +3. The negatives will win by 2. Okay, and then we'll do the exponent here. -2 times -2 is +4. Okay, and remember this means multiply. Okay, I always have students kind of add them all of a sudden, and it just messes everything up after all this hard work. So be careful. This is multiply by A. Okay, all right, let's boot the 4 over. Okay, so -4 divided by +4 is -1. All right, so we can build our equation now. Y equals, I'll just write the general one again, so you know that I'm filling in all the letters here. Okay, so I know my A is -1, and so we're math people, we don't write the 1, so I'm just going to write negative, but we know there's a -1 there. X, we don't fill in. H is, was -3, so we're going to fill that in, and K is 0, okay? So clean it up, and then we get +3, like that, and then there's your final equation. Okay, we're going to try method 2 here now with the same equation. We're going to use the step pattern just because we have a nice graph again. But just warning, if it's not a nice step pattern, like if it's a step pattern like over 1, up a third, over 1, right, up a half, that's a little harder to use the graph for, because this way then you're estimating, you're guessing, and you're not being exact, because we want you to be exact. So that's why I recommend do method 2. Okay, but method 1 over here. But method 2 is nice because it is faster. Okay, but again, you should practice these algebraic skills, get really good at them, just because it always helps build for future as well. So method 2. All right, so we go and find our vertex still. Okay, so that's that point there. So it was -3, 0. Okay, and that's our HK. So we found 2 out of the 3 letters we need. From there, let's do our step pattern. So we know we go over 1, and then it went up 1. So 1, over 1, and then, so I know we're going, we're going down. So down 1. Okay, and then here we are going down 3, down 3. Okay, over 1, down to here, 1, 2, 3, 4, 5, down 5. Okay, so we have our step pattern is -1. Okay, so again, if you're want to analyze, because the A value here is, we're going to use it for the step pattern. So we have a times 1, 3, 5. So the step pattern we found was -1, -3, -5. So what did we have to multiply the 1 by to get -1? 3 by, right? And so forth. So since we had to multiply by -1 to get all of these, our a value is -1. Okay, and now we can build our vertex form equation. So negative only, like that. H is, so, and like if you start getting really good at this too, you know the value. If it's -3, the opposite goes in. So you can kind of even do a shortcut here. Oh, well, I know it has to be +3. Okay, or you can do what we did here. We went -3. Anyway, but if that's confusing here, I'll do it step by step. -3 like that, and then plus k is 0. So cleaning everything up. So we don't need, we need to make this negative negative a positive, like that, and then we don't put the 0 in. Okay, so again, make sure, don't forget the square, the exponent too, because that's the key that makes it the equation a quadratic. Okay, so sometimes when you're building, you kind of forget, and you forget the squared here. Don't forget the y equals as well. Yeah, just clean anything up, like any signs like that if you can. All right, so hopefully that was enough examples to get you through today's material here today. So again, you should be able to build the vertex form equation given clues. Like if I describe the transformation, you should be able to go back to the equation. So that's why it's key that you know the difference between vertical compression, vertical stretch, left or right, up and down, reflection, and the x. You should know exactly what letters that affects and which way it goes and so forth, okay? And then probably the toughest one for today is this one here, C, where if I, tell you reflection, vertical stretch, you know what A is. But if I tell you things like, oh, there's some zeros, okay, at 3 and 13, and then there's a point, how do you figure out everything? So you can find the H value because if there's 2 points straight across from each other in a parabola, in a quadratic, you can find halfway, and that will be where your x value of your vertex is, okay, which is actually h in this case here. So yeah, just kind of look at this one a lot. Make sure practice lots of these, okay? And yeah, so here we had to, if we have a couple pieces of information, fill everything in. There's always one letter that's left, and then you can solve for the letter and the graph. So basically go from a picture of a graph to the equation, okay, with all these different methods that I showed you here. All right, and yeah, so once you get really good at that, that's good. We can move on to some other types of equations with quadratics, okay? So like I hinted, today was vertex, next day will be standard, the other day will be or factored, or and then we'll be mixing them all up together and so forth, okay? All right, so go and practice. I have a worksheet, so there's some textbook questions, and then try the checkpoint.